Hey all, so let's look at some tangents when there are some shifts that happen to figure out how can we find our asymptotes, so on tangents and cotangents. So I'm just going to make something up. Let's say we have y equals, let's do 2 tangent, and then after that let's do 2 theta or x, either one is fine, plus pi over 2. Okay, let's start there. So there are a couple things going on right here. Do you see? I don't have an amplitude this time, but this 2 really means that the first points out off the middle are up 2, down 2. And I know that like tangent kind of sort of, it goes like that. And originally in my mother function, I've got asymptotes at negative pi over 2, and I've got an asymptote at positive pi over 2. Super important that we know that. Okay, so let's see. Originally, the period would be pi. But do you see this right here? So I'm going to take that pi because it's just going from here to here. You've only got half the circle that's happening. So the period would be pi, but then I divide it by 2 because of that. The phase shift, I'm going to tell you, is left. Hopefully you can see the left, but it's pi over 4. And you might be like, why is it pi over 4, not pi over 2? Because, see right here what is happening. In order to, so that the b factor right in front of the theta is 2. And so in order to find out what is my shift, I'm going to like factor that 2 out. And if I factor the 2 out of the 2 theta, it's just theta. If I factor the 2 out of pi over 2, it becomes pi over 4. But let's figure out a different way to do that. So really, I know that in the mother function, the first, I've got an asymptote at negative pi over 2 and positive pi over 2. So let's do this. I'm going to say this 2 theta plus pi over 2. I'm going to set that equal to my pi over 2. That's my first asymptote. Okay, and I can solve this to figure out kind of where that goes. All right, so the pi over 2, let's see. So I subtract pi over 2. Oh, that's interesting. I get 0. So 2 theta equals 0. So I divide by 2. Okay, that means that this asymptote is now going to be at 0. So I'm just going to grab my little asymptote, and it's going to be at 0. Probably because it shrunk and it shifted. Okay, so let's see what is going to happen on the next thing. So now I've got to set the other one equal to this. Okay, so 2 theta plus pi over 2 equals negative pi over 2. Okay, so minus pi over 2 minus pi over 2. Okay, so I've got 2 theta equals negative pi over 2. Negative pi over 2 is negative pi. Divided by 2. Okay, so my new asymptote is at negative, because that was negative pi over 2. Okay, and you might be like, I feel like that shifted more than pi. Well, do you see that originally the middle point would have been right here, but then this 2 right here like skinnied it up, and then I shifted it. So really, do you see how the middle point only shifted pi over 2, and then it shrunk? So sometimes if you can find 2, so I find the asymptotes, this really only happens when you have a shift and a number right here. Do you always have to do this? No. Can you always do this? Yeah. And so now I see that my, like it's pi over 2 is the period. And so now I can put all of the asymptotes in. It's just every half pi. So the half pies and the whole pies. Oh gosh, that's like a lot going on there. Oh my gosh. Okay, so do you just see that I've got a whole bunch and it's just cranky graphing, but I've got like it's every 2 pi, or pi over 2, sorry. All right, and then the 0 always goes in the middle. This is what's nice. If you can get your asymptotes laid, then the middle, it's always right there. Because it didn't shift down. Oh, if it'd shift down, I would have shifted down. Okay, and then I know that it didn't like flip over. Tangent goes up for you. It's like that. So it's going positive like this. Okay, and the second, like the number out, is going to be at 2. So it's halfway here at 2, halfway here at 2, 2. Okay, and once I have 1, I can pretty much graph it. There you go. So that is a tangent with all of the shifts and the, so I had a vertical stretch, a horizontal compression, and a shift. Oh my gosh, all sorts of stuff happening.